Welcome to our class on computation of evapotranspiration. This is one of the most important topics we, the agrometeorologists, are concerned in the micrometeorological studies of crop plants. Evapotranspiration calculation is fundamental. So we try to understand all the methods or techniques as far as calculation or determination of evapotranspiration is concerned. First, we try to understand what is Penman equation, what is modified Penman equation, what is Blaney and Cradle equation, what is modified Blaney and Cradle equation, then radiation method, resistance method, aerodynamic method, decorrelation techniques. These things, these are basics that we are discussing. These things I am taking from practical manual on agrometeorology written by me along with my brilliant students. Okay, they are co-authors with me here. Now, see, I would like to impress upon you that see, in any free water surface, this is the free water surface. From free water surface, evaporation goes on depending upon the evaporative power of the atmosphere. This is with reference to general meteorology is concerned. Once again, the evaporative power of the atmosphere determines the evaporation from a free water surface like this. Now, so as far as the crops are concerned, only we should concentrate on two terms, not third term. First one is ETO. This is what I would like to impress upon you. ETO. Second term is ETC. From here, why I am telling you as far as agrometeorologists are concerned, only these two terms are. Let us not go for confusing terms like actual ET, PET, okay, ET from any other source like that. Different terms are there. Not to give any scope for any confusion. So in this book we have given very clearly that only we are going to discuss in class. It's very interesting. See, crop is there, from the crop transpiration occurs. Soil is there, evaporation occurs. So both from the soil evaporation, transpiration from the plant, ET we call it as. Now weather parameters are there. ETO, reference crop evapotranspiration, what we call it as the reference crop evapotranspiration. So what is ETO? That's why I request you, please subscribe to my channel, Agrometeorology, Farmers and Rural Development. There, the concepts of evapotranspiration I have given a separate presentation. There I had given you enough information. ETO, it is the reference crop evapotranspiration. Now, how we get the ETC? When ETO is multiplied with the crop coefficient Kc, we get the evapotranspiration of the crop. Now, see, crop characteristics play an important role here. How ETC adjusted is there, because there are certain stresses involved in the crop production, biotic and abiotic. So, crop is not always supplied with the best environment, the best water supply, the best management practices. That's why here management and environmental stresses, otherwise factors we include as far as adjust, ETC adjust. What is ETC adjust? Once again I would like to say, first ETC, ETO, reference crop evapotranspiration we get from these methods. Then we multiply it with the crop coefficient. Then ETC adjusted also we take it. What is ETC adjusted? We give enough weightage to the management practices, environmental factors here. So in this class, again I am telling you, these are the this is the crop. Okay, this is the crop. This crop is giving transpiration. Okay, from the soil, evaporation, evapotranspiration. So crop characteristics play an important role with reference to reference crop evapotranspiration, ETO. ETC, that is the management practices, and the environmental factors. So this is what I would like to impress upon you as far as the basics are concerned. Now in this class, in just 1 minute, 1 minute, 1 minute and 1 minute, we try to understand what is the Penman equation, what is the modified Penman equation, then what is Blaney and Cradle equation, what is the modified Blaney and Cradle equation. This once again I would like to impress upon you. This is from my book Practical Manual on Agrometrology, written along with my students. They are the brilliant students with whom I worked. Now see, Penman equation, ETC. We wanted finally ETC. How we calculate it? First we go with ETO, reference crop evapotranspiration. This is the reference crop. Okay, keeping the crop in mind, Penman had developed a wonderful equation. What is that? The first Penman equation is equal to ETO is equal to WRN plus 1 minus W wind function. This is the aerodynamic function. Here I have clearly mentioned aerodynamic function. Here in this term, in this particular equations, there are two things we the agrometrologist must remember. First the equation, then the methods. So let us know the equations. What are the values to be substituted in the equation, so that becomes a method. Concept is that they have given the equation, we go for methods and we apply those methods. Technique, science is an wise into the possibilities, whereas technique is the application of science with small instruments or so small machines. Okay, that's what I am going to say here. Now ETO, reference crop evapotranspiration, is equal to WRL plus 1 minus W, a function of aerodynamic E minus C. What are these terms? Now in the Penman equation, ETO, reference crop evapotranspiration, is ETO. W, a temperature and elevation related weighing factor for the effect of radiation. Here the W is with reference to radiation. It is a weighing factor with reference to radiation, temperature and elevation. Now function FU, okay, if you see the FU here, a wind related function. What is that wind related function? I just give you in detail later. 1 minus W. What is 1 minus W? A temperature and elevation. Temperature and elevation related radiation factor. Okay. 1 minus W. From 1 we deduct it. A temperature and elevation related factor for the effect of wind and humidity. Wind and humidity on ETO. Here only the radiation temperature. Here wind and humidity. We take it in the aerodynamic term. Of course, Rn is equal to net radiation. I told you several times. However, Rn is derived from, see, for deriving different parameters. So Penman equation has so many components in the modified Penman equation also. All those components can be derived or estimated from standard tables, absolutely there is no problem. That's why it had gained a lot of importance. Now, see, EA is equal to, of course, evaporation, of course, vapor pressure of the air, millibars. Okay, so ED we just calculate simple formula. Okay, simple. These are the small things which we substitute. If we measure, excellent. If we cannot measure it, we estimate from the reference table. So this is the Penman equation. Here I have given the calculation also. We try to do the calculations after the basics. This is the basics class. Just Penman equation. What is Penman equation? What is Blaney and Cradle method? What is modified Blaney and Cradle method? In this class, we try to understand. Later on, aerodynamic, eddy correlation. Once we understand the basics, then calculation we do it very easily. Here itself, for calculation, I am giving you a very good idea that for every parameter in the Penman equation, there are so many assumptions and tables that were given in innumerable books, particularly FAO, Food and Agriculture Organization, 1956, Penman equation. So ETO is to WRN, 1 minus W, wind function, E minus ED, that is the humidity function. Now, all in millimeters per day only, all. Now, so what is the modified Penman equation is, okay, so based on the intensive studies, why it has become modified Penman equation is there. What is modified Penman equation? Usually we encounter, this is the basics class, I should clarify this, that's why. So based on intensive studies of the climatic and measured, of course, gross ET evapotranspiration data from various research stations in the world and the available literature of the predictions of the ET and ETO. Okay, Doornbos and Clout in the year 1977, what they proposed is modified Penman equation. This is the modified Penman equation. Simple. Here is the weighing factor is there for radiation. Here is the wind function is there. This is the aerodynamic term. This is the radiation term. Same things only. Just for your academic interest, quickly I will read ETO. Here also we calculate ETO. As we, the agrometeorologists, we should know only ETO, reference crop evapotranspiration only. Once we get the reference crop evapotranspiration, if we multiply it with the crop coefficient, okay, crop Kc, we get the evapotranspiration of the crop in millimeters per day. Now here, as far as the modified Penman equation is concerned, once again, I would like to impress upon you that these values, okay, if we measure it is excellent. If we cannot measure, we can derive from the different tables that were proposed by Penman for across the globe, whether it is torrid zone, whether it is a humid zone, whether it is a temperate zone, for a different duration he had given there. Simply, I would like to just radiation term, aerodynamic term, what are those? I would like to say like these original Penman equation from there. Now ETO is the reference crop evapotranspiration. W, what is W here? Simple. Temperature related weighing factor for the effect of radiation on ETO. Temperature related, okay, weighing factor. Rn, net radiation, okay, in the net, to calculate net radiation, if meteorological observatories are not there, just if we have sunshine hours, from there, okay, also Penman had given the scope for calculating the net radiation, okay, so that's why innumerable tables he had proposed, okay, then after that, of course, for your academic interest, I would like to tell you, Rn net radiation, okay. What is the net radiation? The difference between the incoming and outgoing is the net radiation daytime. It has got positive values because sun source is there, soil becomes the sink. Net radiation values in the negative in the night, during the night time. Why they are negative? Because soil becomes the source, there is no incoming radiation. So only outgoing is a negative value. So from in that, just for your academic interest, this we have mentioned. I have mentioned along with my beloved student. What is that? Net radiation, okay, RNS minus RNL. Okay, what is RN, what is RNL? I have told several times in the solar radiation chapter, several times I told. Please subscribe to my channel there. In the agrometeorology, farmers, all these things I have done it there. Even a calculation of net solar radiation from Campbell-Stokes first and same equation we mentioned it here. Then what is the 1 minus W, same 1 minus W here like original. So what is the FU? It's a function of the wind related function. FU is equal to 0.27, okay, into 1 plus U by 100. EA, saturation vapor pressure in millibars at the mean temperature in the degree centigrade, mean actual vapor pressure of the air, ED, okay. But what is the C here? Adjustment factor to compensate for the day and night weather effects. Please, twice I will read. What is this C here? 3 times I will read. Adjustment factor for compensation for the day and night weather effects. Adjustment factor to compensate for the day and night weather effects. Adjustment factor to compensate for the day and night weather effects. Why I am stressing upon this point is, in the year 1800, Dalton himself had proposed this particular C concept. 1800, though Penman had proposed the work, most of his work were around 1948. For 1948, he proposed the equation. That means almost 140 years before, Dalton worked with the C, taking the philosophy of that day and night. That's what I am doing. During the daytime, net radiation is positive. During the night, most of the days of 365, during the night time, negative net radiation is there. That's why he had included this one. That's why I am telling you, see, that you should remember how you get it. It's a weighing factor. It is available from the tables proposed by Doornbos and Proust, okay, from Penman only. Now let us go to what is Blaney and Cadell method. What is the modified Blaney and Cadell method? First one is Blaney and Cadell equation. First, please understand 3 terms. Equation, so first concept. then equation, then method. Concepts are of Penman and then Bland and Cadell. Then they developed the equations. They have not proposed, developed. From a developed equation, we have to determine or we have to calculate. While calculating for the general location across the globe, several assumptions they have given, scientific proof for those assumptions. In addition to the assumptions, they have given how to calculate for different locations, the parameters that are required for the in the equation, the components in the equations. Now, this is the equation only. What is the Bland and Cadell original equation? Bland and Cadell original equation is equal to PET 0.0173 TA minus 0.314 Kc into TA dl by 4465.6 into 25.4 millimeters per day. This is how we get it, PET. So I stand by my word that PET has less significance as far as we agrometeorologists and agrometeorologists or particularly micrometeorologists are concerned, because PET is used by the meteorologists, climatologists for some aridity index or some drought indices. So let us forget that word as far as evapotranspiration is concerned. That's why I request you, please subscribe to my channel. I have given enough information why we should give less importance to PET. We should give importance only to ETO and ETC calculation by multiplying the crop coefficient factor, depending upon the vegetative reproductive activity stage only. Now, in this equation, the Bland and Cadell method PET have given. So, what is that ETO, reference crop evapotranspiration in millimeter per day for the month considered? T, mean daily temperature in degree centigrade over the month considered. P, mean daily percentage of total annual daytime hours. Okay. C, adjustment factor, which depends upon the minimum relative humidity, sunshine hours and daytime, wind estimates. Finally, once we get the, of course, PET from there, we multiply it with the crop factor and the ETO. However, PET is a little importance as far as this one is concerned. Now, so what is the modified Bland and Cadell method like Penman equation? What is the modified? ETO is simple. ETO is equal to C into P 0.460 plus 8 millimeters per day. Simplest thing, reference crop evapotranspiration ETO. Reference crop evapotranspiration ETO is equal to T, mean daily temperature in degree centigrade over the month considered. P, mean daily percentage of total annual daytime hours. C, adjustment factor, which depends upon the minimum relative humidity, sunshine hours and daytime wind estimate. So here another component also Bland and Cadell have given as far as C is concerned. C was first introduced by Dalton in the year 1800. So first it is a concept they have proposed. So he had proposed. So these scientists in the particularly Bland and Cadell work, it goes around 50s after Monty's work. So much of development in the equation have come. So this is what I would like to impress upon you, such that you can calculate the ET, evapotranspiration of the crop. Once again, I would like to say this is the basics. I introduce you to the equation, how we can get the components in the equation. Finally, first concept they have proposed, they have given us the equations. Then in the equations we get some estimates, some measured values. Where measured values are not available, we go for the estimates from the perfectly scientifically drawn, scientifically given tables. This is what I would like to impress upon you. Thank you very much for your patient hearing.